All right, guys, today we're going to talk about multiplying and dividing fractions. We're going to review our rules when you have fractions and fractions. So we are going to go through multiplying first. So in order to multiply fractions, our rule is going to be top times top and bottom times bottom. We're going to multiply our numerators and our denominators together, and it's just literally straight across. Top times top, bottom times bottom. So 3 times 1 is just going to be 3, and 5 times 2 is just going to be 10. And so that is the solution for those two fractions multiplied together. Now, if we are dividing fractions, our rule is keep, change, flip, or KCF. Okay, so keep means we're going to keep our first fraction. Change means we're going to change our fraction to multiplying, our symbol to multiplying. And flip means we're going to flip our second fraction over. So flip meaning I'm going to take the bottom and it's going to become the top. Okay? So I'm going to say 2's on top now and 1's on bottom now. And again, all I did was flip this second fraction from top to bottom. That is called the reciprocal. And now it's a multiplying problem, right? We have our multiplication symbol in the middle, and our rule was top times top, bottom times bottom. So again, I'm going to multiply numerator times numerator. 2 times 2 is 4, and 7 times 1 is 7. And that is our dividing rules, okay? Dividing rules. All right, remember that if we have a whole number, remember whole numbers are going to go over 1. Okay, so an example of that, let's say I have a 4. Well, that's just 4 over 1. Okay, anytime I have a whole number like 7, that is literally just 7 over 1. Okay, so easy to make those look like fractions. So let's go over some examples with whole numbers. So our first example is a multiplying example. So first thing I'm going to do is I'm going to take my whole number 12 and I'm going to put it over 1. And then I'm going to draw my arrows because it's top times top, bottom times bottom. So what's on top? We have a 1 times 12. A 1 times 12, right? And so what is 1 times 12? Well, that's just 12. And then we have a 4 times 1 on the bottom. So 4 times 1 is 4. Now, what we end up with here is an improper fraction. Remember, we never leave our fractions improper. So improper meaning that my cowboy, my numerator is way larger than my horse, okay? So big cowboy, small horse means we need to cowboy and horse divide, okay? So I'm going to come over here to the side and I'm going to say, okay, 12 is my cowboy, so he lives inside, boots and hat. And then 4 is my horse, he goes outside. So can 4 people sit in one chair? No, but 4 people can sit in 12 chairs 3 times. So 3 times 4 is 12. And I zero out and I made sure, did I reach my decimal? Yes. So this 12 divided by 4 equals 3. Just a whole 3. Okay? And that is multiplying with a whole number. So let's divide with a whole number. So remember, our rule for dividing is keep, change, flip. Okay? So first things first, I'm going to put my whole number over 1. And then I'm going to label KCF. So I'm going to rewrite my problem. I have keeping my first fraction, 6 over 1. I am changing my symbol to multiply, and I am flipping my second fraction over, and so the 5 will be on top, and the 2 will be on the bottom. Now it's a multiplying problem, so I draw my arrows, top times top, numerator to numerator, and bottom times bottom, denominator to denominator. All right, 6 times 5 is 30. And 1 times 2 is 2. So what happened again? We had another situation where we have a large cowboy and a small horse. So remember, anytime you have a large cowboy and a small horse, we are going to cowboy and horse divide. So cowboy on top, horse on the bottom, 30 lives in the house. That's my cowboy. And 2 stays outside. Can 2 people sit in 3 chairs? Yeah, 1 time. 1 left over, bring down my 0. Can 2 people sit in 10 chairs? Yes, 5 times. I 0 out and I check, am I to my decimal? Yes. So the answer to this problem is a whole 15. A whole 15. All right. So now let's look at it when we don't have just 2 fractions. Now we have a word problem. So this is how we're going to see it in 7th grade. We saw it much more like this top part in 6th grade. And so now we're going to move on to a word problem style in 7th grade. So it says 50 students. So notice that they're kind of tricky there, and they wrote it as a word. So 50 students were surveyed about their favorite sport. So I'm going to come up here and say total is 50. Okay. 50 students were surveyed about their favorite sport. The statements shown summarize the results of the survey. So the first statement says 1/2 of the students chose football. So last year we learned that anytime a fraction is followed by the word of, it means to multiply. So we are going to do 1/2 of 50. 50 is a whole number, and whole numbers go over 1. So to find out how many students chose football, this is for football, I'm going to do half of, or times, my total of 50 students. So again, multiplying is top times top, so 1 times 50 is 50, and bottom times bottom, 2 times 1 is 2. So what is 50 divided by 2? Well, we can cowboy and horse that, but I know that it is 25. So again, I'm going to label that as football. All right, let's read my next statement. So my next statement says 1/5 of the students chose basketball. So this time I'm going to go ahead and underline basketball, and I know of after a fraction means multiply. So I'm going to set it up. 1/5 of 50 again. 50 is still my total. And I'm going to put that whole number over 1. So my rule is still top times top. So I say, okay, I'm going to change colors so we don't get confused here. So top times top. 1 times 50 is 50. And this time, 5 times 1 is 5. So again, I have that improper fraction where my cowboy is larger than my horse. So I need to cowboy and horse divide. Again, 50 divided by 5, we would cowboy and horse divide. I know is 10. I know it is 10, and I'm going to label that as basketball. Again, notice I'm keeping everything nice and organized and labeled so that when I read my question, I'm ready to go. Then it says the remaining students. So what does the word remaining tell us? Remaining means we need to subtract. So obviously we're going to start with our total so that we can find our soccer players. So we had a total of 50 students, and we're going to subtract my football, and I'm going to subtract my basketball, and that will equal my remaining soccer players. So 50 minus 25 is 25, and 25, so this is 25. I solved it, and I bring it down. And then 25 minus 10 is 15. So I had a remaining 15 students, and they chose soccer. So now I can read my question statement, and it says how many students surveyed chose soccer. So which one are we looking for? We're looking for the soccer number. So how many students chose soccer? Well, that was 15. Okay, 15. Oops. Disappeared. 15. Okay. And again, I knew that this was a multiplying problem because it said fraction followed by the word of. fraction followed by the word of, okay? And remember, 50 was my total, and whole numbers go over 1, okay? And the last thing we need to remember is that remaining means subtract. So we're going to take our total and subtract. All right, and just a reminder down here at the bottom that if for some reason you have a problem with mixed numbers, so not just a regular fraction like these, but if you have mixed numbers like these where you have a whole number in front and a fraction, remember we are going to solve those as decimals. So we would not solve this as a top times top, bottom times bottom. We would change them, cowboy and horse, and say this is 10.4 times 2.25. Okay, so anytime we have mixed numbers, meaning we have a whole number and a fraction, we are going to solve those as decimals. All right, so that's just your reminder. All right, that's multiplying and dividing fractions, guys. Go practice.